Okay, so before starting the discussion of this type of question, one thing I need to clear, that you must have experience that when you are riding a bicycle, then when you are moving in the direction of the wind, in the direction of the wind, then you have to apply less effort, and automatically you see the speed of your bicycle is increasing, right? Right? Have you experienced that?
Yes, ma'am.
Okay.
Yes,
Uh,
ma'am.
and the other condition is when you are moving against the direction of the wind, then you have to apply more and more effort, and you still see that the speed is not really like it's quite slower, right? So this happens due to the situation that actually when you are moving in the direction of the wind, then you are applying one speed. It's your speed. That's why I am writing, just for understanding, it's your speed. I mean the speed of the bicycle. Okay. Plus the speed of the wind is working along with you. That's why you feel that, okay, with very less effort the speed is increasing and increasing and increasing, right? Otherwise,
Yes, ma'am.
the next condition is when you are moving against the direction of the wind, then whatever speed you are applying, okay, wind is working against you, and that's why you feel that speed is, okay, really less and slow. Okay, so this happen in all the situation, in boat also, when the boat is moving in the direction of the wave. Okay, in the direction of the wave, and wave over here we will be calling in the direction of the stream. Okay, actually in our language we say in the direction of the wave, here we'll be calling in the direction of the stream. Okay, so when the boat is moving in the direction of the stream, that means boat's speed and the stream's speed both are working together when in the direction of the wind. Okay, not wind, the stream. And if it is working against the direction of the stream, then boat's speed, okay, whatever speed boat will apply, the stream is working against that. The stream's speed is working against that. And in each and every situation, see, I am writing the boat's speed at first, because even though the stream's speed is working against, still the boat is moving. That means both boat's speed is still bigger, right? The larger number. Getting it?
Yes, ma'am.
Okay, so you need to understand this two situation. Now I am going to name this two situation. Listen to me carefully. When the boat is just going in the direction of the stream, that's called downstream. That's called downstream case. Okay, downstream. So anytime, anywhere you will read the downstream is mentioned, you will understand, okay, the boat is moving in the direction of the stream, and here you need to add both the speeds. Here you need to add both the speeds. Is it making sense? And when the boat is working against the direction of the stream, that case is having a name, and that is called upstream. So whenever you will see this terminology upstream, you need to understand that the boat is working against the stream. That means boat's speed minus the stream's speed. Making sense?
Yes, ma'am.
Okay, now let's discuss this question number 36. Now just keep it in your mind and write it in your notebook that downstream means added together, upstream means subtracted, downstream means in the direction, upstream means against the direction. Okay, let's read question number 36. Speed of a boat in still water is 15 kilometer per hour. It goes 30 kilometer upstream and return back at the same point. So let's read it carefully. So speed of a boat in still water is this one. That means actual speed of the boat is this one without any effect. Okay, still water means just a still water. Okay, without any wave in consideration, without any stream in consideration, in still water. ओके, इन हिंदी भी से रुके हुए पानी में बोट का जो स्पीड है वो 15 किलोमीटर पर आवर है. दैट मीन्स विदाउट एनी अदर force, without any other disturbance. Okay, so that means the actual speed of the boat is 15 km/h. Now the other condition says that, let's read it. So at first you are having the data, okay, that speed of the boat is 15 km/h. It goes 30 km upstream. Upstream means you need to understand against the direction. Okay, upstream means against the direction. It goes 30 km upstream. That means for upstream case, distance is 30 km. Okay, and returns back at the same time. Return back. See, if the boat is going in upstream, that means when it will return back, that will be downstream for the boat. Are you getting it? Are you understanding?
Yes.
When the boat is supposed from point A to point B, the boat's job is to pick the people from point A and just drop them up in point B. Then pick the people from point B and just drop them on point A. Okay. So suppose this way it is working. So it's picking up the people from A, dropping at B, picking up the people from B, dropping at A. Okay. So when the boat is going from A to B, it was upstream. That means the boat has to go against the direction of the stream. But when it will come back from B to A, it will be downstream case. Here it is not written, but you need to understand it by yourself. Okay, that the boat is returning, that means now it is facing downstream situation. Okay, same distance, 30 km is it has gone, 30 km it will cover to come back. Okay, at the same point in time 4 hour 30 minutes. That means going from A to B and then returning back to A all together. Okay, if the time over here is T1 and the time over here is T2, so here T1 plus T2 is given as a 4 hour 30 minute. Are you getting it? Are you getting it? Yes or no?
Yes, ma'am.
Okay, find the speed of the stream. See, we don't know the speed of the stream, so you have to take the consideration that suppose the speed of the stream is X or maybe Y. Okay, suppose the speed of the stream is, you can call it X, you can call it Y, your wish. Suppose the speed of stream is, I'm taking Y, you can also take X. Okay, now we will make the equation. How? So we will write speed distance time in first situation, speed distance time in second situation. Okay, for upstream, speed is equals to distance by time, but this formula we need to write it in the form of T1 T2. Okay, so that we can add T1 plus T2 is equals to the given time. So I am writing the same formula. Okay, can I write time is equals to distance by speed? Can I write? Can I write the same formula in this manner?
Yes, ma'am.
Yes, miss.
Okay, distance over here is 30 kilometer. Speed over here is, this is the downstream, this is the upstream situation. So you have to be careful. Speed over here is, if you have assumed this speed as a Y, so speed, actual speed which is working on the boat is this. Where was the boat's speed? 15. So actually it is 15 minus Y. Are you getting it? This I was explaining you till now. Making sense?
Yes, ma'am.
Whereas for the other, this is T1. Whereas for the other case T2, it is again 30 kilometer. Okay. But this time the speed is working, that 15 plus Y is working on the boat. Now in the question, it is written that T1 plus T2. In question, it is written that all together the time taken by the boat is, Can you hear me? Can you hear me?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
miss.
Just a moment. No, I'm not able to scroll. I'm not sure why it's started lagging. It was 4 hour 30 minute, right? Let's frame the equation. Okay, 4 hour 30 minute we will be writing in hour. Okay, so 4 hour 30 minute, that means T1 plus T2 is equals to 4 hour 30 minute. Okay, 4 hour 30 minute, can I write 4 plus 30 by 60? That means 4 plus 1 by 2. That means 4 2 times 8. 9 by 2. Can I write it is equals to 9 by 2? If I am audible, please listen to me. Okay, because I'm not able to write for now. I need to just stop sharing the screen, I believe. Can you hear me?
Yes, ma'am.
Okay, please make the equation by yourself that T1 plus T2 is equals to 4 plus 30 by 60. Okay, this 30 minute we are going to convert. Yeah, now I'll be able to write. This 30 minute will be converting in hour. Please make the equation and tell me, are you able to solve the equation or not? Please make the equation. Can you hear me?
Yes, ma'am.
Just a moment, no. I'm just stopping the screen sharing. Yeah, can you hear me now?
Yes, ma'am.
Okay, so let me solve it on OneNote. Have you understood the question, everyone?
Yes, ma'am.
Okay, so this type of boat based question do come in exam. Okay, so be careful that this way we will just understand that downstream means what, upstream means what, and this way you need to solve the equation. Okay, I am sharing the screen. There we will solve also this equation. Can you see this screen? Have have you noted the data from there? No? Can I write 4 hour 30 minute as a 4 plus 30 by 60? That means 4 plus 1 by 2. That means 9 by 2. Can I write it this way?
Yes,
Yes.
ma'am.
Yes, miss.
Ma'am, could we
Yes.
write in minutes?
Yes, Inan. Can you please repeat?
Could we write in minutes?
Can we write it in minute? No, because the speed which was given to us, that was kilometer per hour.
Okay,
Okay,
ma'am.
the speed was given to us, it was 15. The boat's speed was 15 kilometer per hour. So if the speed is in hour, then we need to keep this the total time also just only in hour. Okay, so T1 was distance over speed, and that's for upstream case and downstream case. So one time we were having 15 minus y, and another time we were having our distance was given as 30 kilometer. Here also 30 kilometer downstream, that means 15 plus y, right? And from here we are trying to find the y value. Once we will take out y, we will say that yeah, we got the speed of the stream. Okay, so as you can see, you need to take out the LCM. Okay, I'm just repeating, just copy pasting over here. We'll be having 30 over 15 minus y. We'll be having plus 30 over 50, 15 plus y. Okay, most of the time I just do till here and ask the students to solve it after this and find the value of y, but I have seen the students struggling with the solution part as well. So let me show it to you that how exactly we need to solve it. Of course we need to take out the LCM and you are also understanding, but be careful while finding the solution. Let's do it. So LCM will be, see, these two are completely different. Okay, 15 minus y, 15 plus y are completely different from each other. So your LCM will be 15 plus y and 15 minus y, right? Even though terms are same, brackets are completely different from each other. Okay, you cannot say it same. That's why you are taking out LCM in this manner. Now in numerator, I have always explained you in this manner that you will be comparing the older denominator with the current denominator. In the LCM part, anyone having any confusion? Samya, Rayan, Bharti,
No, ma'am.
No, ma'am.
Inan,
No,
Afrin.
ma'am.
Okay. Always you should compare your older denominator with the current denominator. You will find that what has been multiplied. Clearly you can see 15 plus y has been multiplied. So the same 15 plus y you need to multiply. Okay, with this 30. Or you can write 30 at first as well, your wish. If you are comfortable writing 30 at first, so that after this step you can apply distributive property, please write it this way. Plus the previous denominator, the second denominator with the current denominator, if you will compare, you will realize that 15 minus y is the extra that we need to multiply in the numerator as well. Other side is still we are having 9 by 2. Is it crystal clear to all of you?
Yes, ma'am.
Okay, now there are so many ways to simplify it, and one of the ways, are you realizing that distributive property? Okay, just the reverse of distribute. Here we can take out common. 30 we can take out common from both the term. See, the distances are same in numerators part. Can we say that 30 can be taken out common from the numerator? See, you can multiply this 30 with 15. You can multiply this 30 with y. Then the same thing, 30 you can multiply with 15 and 30 you can multiply with y. But you can also take out 30 common. And you can just write that you are left with 15 plus y over here plus 15 minus y. Is it making sense?
Yes, ma'am.
You could have done that way as well, and you can do this way as well. I am showing you this way because we don't even need to multiply first. And while doing this curly bracket, while just simplifying this curly bracket, maybe few terms will cancel out each other. Okay, so let's move. In denominator, we are having 15 plus y, 15 minus y. That means 15 square minus y square is equals to 9 by 2 you are having. Okay, let's move. 30. When you will simplify the curly bracket, you will end up getting 15 plus y plus 15 minus y. Y gone. 15 plus 15 will be 30. And this 15 square will be 225 minus y square is equals to 9 by 2. Now you are having fraction on the left side and a fraction on the right side. A fraction on the left side, a fraction on the right side. Crisscross multiplication you can do. Or you can say the denominator from the left side will go to right side and will get multiplied. And the denominator from right side will come to left side and will get multiplied. Is it making sense? So you will be having 3 times 9. Actually, you are having 900 already. 2 will come and get multiplied. And 9 over there is still there. 225 minus y square. Is it clear?
Yes, ma'am.
After performing this step, okay, you can multiply this 9 with this one. But I realize that this 9 and this 900 will cancel out each other. If I will bring this 9 in the denominator, then I will be able to reduce the terms. Okay, so if it is possible to make the numbers smaller rather than making it larger, huge and huge number, please make it smaller so that you will be able to solve the quadratic equation easily by doing the factorization or maybe by using the quadratic formula. See, even for using the quadratic formula, if the numbers are really smaller number, okay, your square root part, your calculation will be simpler. Okay, so this 9 I'm taking to this side and it is just 900 into 2 was still there over 9 is equals to 225 minus y square. You can do your way, I am doing my way. At the end, your equation and my equation will be same. Making sense? Are you getting it?
Yes.
Okay,
Yes,
so it
ma'am.
is 200 and that is 225 minus y square. See, we don't even have to use quadratic formula or anything. See, equation is really simple. Okay, y value easily we will be able to find. Okay, we can say minus y square if you
5.
want to put it over there, or you want to take the y square over here, your wish. If you will leave y square over there, yes, anyone want to ask anything? Can you see? Minus 25 is equals to minus y square. Y square is equals to just 25 and y value is plus minus 5, right? Right. We are talking about the speed. We'll be taking the
Yes, ma'am.
positive result. Got it?
Yes, ma'am.
So this is how we'll be solving this type of question. Boat related question. You should be comfortable with boat related question. Okay, I also want to take a train related question. Just a moment.
Ma'am, I have a question.
Yeah, please.
So, 9 into 225 minus y square you took as a denominator to other side, right? But
Yeah.
I did like a normal multiplication, but I got 15
Let's do the
as the
normal multiplication. Okay. As I said, you can do your way. I'm doing my way. Okay. So we are having from here. Okay. I'm trying to use the basic approach. Okay. Just distributive property on the other side. So we'll be having 9 2 times 18 and 9 into 225. I have to do the multiplication. 9 5 times 45. 5 carry 4, 9 2 times 18, 90, 20, 21, 22. 2 carry 2, 9 2 times 18, 90, 20. 2025 minus 9y square. Any doubt from here to here? This 2025, if you will take to this side, you will be having 1800 minus 2025. That is equals to, be careful, minus 9 is y square. Okay, 2025, 1800. Integer chapter you have learned so well. If you are subtracting a bigger number from a smaller number, no worries. Okay, we will be getting 10 minus 8, 225 minus 225. Are you getting it? Everyone, is it crystal clear so far?
Yes, ma'am.
Yes,
ma'am.
ma'am.
2 times 18, 90, 20, 21, 22. 9 5 times 45. Can you see the result? Even though you are not doing my way, don't follow my way. Always solve the equation your way. Okay, because that way you are clear, you are confident that yeah, your solution. But yeah, at the end, your answer, my answer has to be same. If it is not same, then show me your steps. I will tell you where you did the mistake. Can you see? Still, we got y square as a 25. Yes, Inan, where exactly you have done the mistake?
I have done the mistake as I didn't actually multiply 9 with y square, that's why.
Okay. So y value is plus 5 and y value is minus 5, and still we'll be choosing the positive result because we are talking about the speed of the stream. So the speed of the stream y is equals to 5 kilometer per hour. Clear to all of you?
Yes, ma'am.
Okay, this is how you are going to deal with boat related question. Whenever you are having a speed distance time related question, you will be creating speed distance time relation from the first case, first condition which is given to you. You will be creating the second equation as per the given condition, and then you will see how to solve this two equation by using the method pair of linear equation. You can use method of substitution, will always help you. Now I was telling you that I also want to take few question, I mean the train related question or something. Just a moment, let me check. Okay, so the train related question, I can see it is exactly just the speed distance time one. Okay, we don't need to discuss it separately. Okay, a fast train. I'm just showing you the equation. After that, I'll leave it. You will be able to solve it by yourself. So a fast train takes 1 hour less than a slow train for a journey of 200 kilometer if the speed of slow train is 10 kilometer per hour, less than fast train. Find the speeds of two trains. Okay, let's see what to do. So a fast train takes 1 hour less than a slow train. A fast train, two situation is there. Okay, one is for fast train, another is for slow train. Are you getting it? Okay, two cases are given, one for fast, another for slow. So a fast train takes 1 hour less than the slow train. Okay, so if the slow train is taking, if the slow train is taking time t, then the fast train is taking 1 hour less. Getting it? Getting it?
Yes, ma'am.
Okay, for a journey of 200 kilometers, so both are covering 200 kilometers. Okay, if the speed of the slow train is 10 kilometer per hour less, so speed over here and speed over there. Okay, you can take the time and speed in terms of x and y as well. Okay, if you are taking that as a y, so you can say y minus 1. If speed you are taking as a x, let's see which one is dependent on which one. So if the speed of the slow train is 10 less than fast, so you are taking fast as a x, then the slow will be x minus 10, right?
Yes, ma'am.
Now you will try creating a speed distance time from the first relation and a speed distance time from the second relation. How? Just create it. Speed is equals to distance by time. Okay, speed is equals to your distance is, this is the distance and time is y minus 1 and speed over here is just x. Just x. Similarly, speed is equals to distance by time. So speed over there is x minus 10, distance over there is 200 and time over there is just 5. Now method